Bismillahirrahmanirrahim. We are discussing the lecture number 3, and this is the continuation of the lecture number 3, and this is the third part. And the course title is Statistics and Probability Theory. In previous parts, we have discussed presentation of data, in which we have discussed how to construct a histogram. Then also we have discussed how to construct a bar chart. In this part, we will concentrate how to make a multiple bar chart. Multiple bar chart. A multiple bar chart shows two or more characteristics corresponding to the values of a common variable in the form of grouped bars whose lengths are proportional to the values of the characteristics, and each of which is shaded or colored differently to aid identification. This is a good device for the comparison of two or three kinds of information, for example, imports, exports, etc. In simple bar chart, we construct only one bar against the variable. Now here we have years 1965 to 1966, 1970 to 71, and 75 to 76. And each year, for each year, the data is collected for two characteristics, area and production of the cotton. So how to construct the multiple bar chart for this particular information? So again, we will construct the y-axis and x-axis. So this would be the starting point 0, and as you can see that as you have to locate both the information for the characteristic that which is area and production of cotton on the y-axis. So you have to concentrate on both columns to set the scale for the y-axis. Now as you can see, the minimum value is 1588 and the maximum value is 3420. So you have to set the scale on the basis of the given information. So this y-axis represents the area and production of cotton, whereas x-axis will locate the years, as years are the categories. So this one is, we will start it with 600. We will keep the distance of 600. The very first year is 1965 to 66, and the area is 2866 and production of cotton is 1588. So let's suppose that we will construct a key here. This is a key. So we have production of 1588 and their area is 2866 for the year 1965 to 66. So as area is in blue color, so 2866, it could be somewhere here, close to 3000, and I will mark it here. And this bar with blue color represents the area, and the corresponding production of cotton is 1588, which should be somewhere here, and it will be like this. So this is the representation for the year 1965 and 1966. We will continue in the same way to construct a multiple bar chart. Next one is 1970, and again we will change the color according to the characteristics. As area is 3233, so it would be somewhere here, 3233. It should be somewhere here. So we will construct the bar which represents the area, and for production we will change the color, and production is 2229, 2229, it would be somewhere here. So this would be like this. So this is the bar which represents the production of the cotton for the year 1970 and 71. And the next year is 1975 to 79. Keep in mind that the difference between the bars should be same. This is the area between the 2 years, so this distance should be same, as I'm not using any scale or ruler here, so there could be some difference, but whenever you draw it on the graph paper, so keep in mind that you should leave the equal number of boxes between each category. Now, the year 1975 till 76, the area is 3420. It should be somewhere here, and should look like this. And for production, it is 1937. It would be somewhere here. So now the multiple bar chart is constructed. This blue color is representing the area, and this purple color is representing the production. So this is multiple bar chart. You can have more than two categories as well, or more than two characteristics. So if there is a third characteristic, so you will construct a third bar here corresponding to each year. If you want to see the clear picture, a more clear diagram of multiple bar chart for this particular example, so this is the more neat picture as it is copied from the book. So this filled area is representing the area in acres, and this multiple bar is representing the production in bales, and each bar is corresponding a characteristic of the variable, which is the year. Frequency distribution of discrete data. So how to construct a frequency distribution of discrete data? As in continuous data, we have constructed the frequency distribution by making class limits, class boundaries, and then we calculated the class marks as well. If you want to see that the data is discrete, just go through the statement, and statement is saying that a survey of 15 retail establishments had assistants, excluding proprietors as follows. So this data is basically for the number of assistants. So obviously number of assistants are discrete, and there could be 0 assistant, 1 assistant, 3 assistant, 1 assistant as well. So if you find the minimum and maximum value in the data, so the 0 is the minimum value in the data, and this 9 is the maximum value in the data. So what you will do, number of assistants we usually represent it with small x. So the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As we have the minimum value 0 and maximum value 9, we started from the value 0 and stopped at 9. So now what we will do, we will mark the tallies, and so if you go back to data, we will go the row wise. So first value in the data is 2. So we will mark a tally corresponding to the value 2, which is here, and this is the tally. Next one is 3. So we will mark a tally against 3. Now next one is 9. Here we will mark it. Next one is 0. We will continue in this way, and in the end we will mark the frequency, which is number of establishments. And if you want to see the complete picture, so this is the complete frequency distribution of assistants in 50 retail establishments, and each category corresponding to its number of observations, And this is the frequency distribution of the assistants in 50 retail establishment. If you sum the frequency, the answer should be 50.